Welcome to the class. The last class I have discussed some statements. Based on that we did some problems on finding the inverse Laplace transformation. Next, inverse transform of integrals. If L inverse of f of s is equals to f of t, that is nothing but Laplace transform of f of t is equals to f of s. Then L inverse of integral s to infinity f of s ds is equals to f of t by t. This is same as Laplace transform of f of t divided by t is equals to integral s to infinity f of s ds. That means this is the statement: inverse Laplace transform of integrals is same as in the Laplace transformation is divisible by t. In the Laplace transformation it is divisible by t. The divisible by t statement is same as inverse transform of the inverse transform of the integrals, right? Integral is transformed to f of t by t. Right, now coming to one problem. Here evaluate L inverse of, take one problem here, integral s to infinity 1 by s into s plus 1 by s into s plus 1 ds. We need to evaluate this one. So here it is, instead of f of s, what is there? This is considered to be our f of s. So let f of s is equals to 1 by s into s plus 1. This, if we decompose into partial fractions, this can be written as 1 by s minus 1 by s plus 1. Now L inverse of f of s is equals to L inverse of 1 by s minus 1 by s plus 1. By using the linear property, L inverse of 1 by s minus L inverse of 1 by s plus 1. L inverse of 1 by s is equals to, we have L of 1 is equals to Laplace transform of t is equals to t to the power of n is equals to, here it is n factorial divided by s to the power of n plus 1, and being a positive integer, this is same as L of 1 by s to the power of n plus 1 is equals to t to the power of n divided by n factorial, n belongs to z plus, being positive integer. Here it is 0 plus 1, we may write it here, n plus 1 it is 0 plus 1. So what I am writing here, t to the power of n, t to the power of n, it is nothing but, here it is L inverse of 1 by s, it is directly you can write it, it is t, that is 0 factorial divided by s to the power of 1. So it is here L of, sorry, it is 1, t to the power of 0 is 1, no? Yes, t to the power of 0 divided by 0 factorial, it is nothing but 1 minus, let's applying the first shifting theorem. Here instead of s, what is there? S plus 1 is there. So we can write it e to the power of minus t into L inverse of 1 by s. So this is same as 1 minus e to the power of minus t into 1. So which is 1 minus e to the power of minus t, that is our f of t. Right, now by applying this theorem, we can write the integral here. L inverse of integral s to infinity f of s ds is same as L inverse of integral s to infinity 1 by s into s plus 1 ds is equals to, here it is what we have, 1 minus f of t divided by t. F of t we have 1 minus e to the power of minus t divided by t. This is the evaluation process. Like this, whatever the problem is there, then you should take the f of s, find the L inverse of f of s, you will get the f of t. This is simple, no? First choose the f of s, then find out the L inverse of f of s, will get the f of t, function of t. So if you take the integration, transformation of the integration, integral s to infinity f of s ds, the function becomes, already we have the f of t like this, f of t divided by t. This is the inverse transformation of integrals. Next, next one, multiplication power by powers of s. By powers of s if L inverse of f of s is equals to f of t, capital F of t, f of 0 is equals to 0, then L inverse of s f bar of s is equals to f dash of t. That is nothing but this is the statement from the transformation of the derivatives in Laplace transformation. That is, Laplace transform of f dash of t is equals to s f bar of s minus f of 0, right? We have the in Laplace transformation of the derivatives, Laplace transform of f dash of t is equals to s f bar of s or s f of s minus f of 0. Here what I am taking here, f of 0 is equals to 0, so 0 s into f bar of s. So we take out this L to the right side. L inverse of s f bar of s is equal to f dash of t. The transformation of the derivatives in the Laplace transform is same as multiplication by powers of s in inverse Laplace transformation. Right, this is a statement here. Now we take one problem on this. Evaluate L inverse of s square divided by s square plus 4 whole square. S square plus 4 whole square. Right. So I think we've taken this type of problems in the previous class. L inverse of s square divided by s square plus a square whole square. Right. In this way we may find this one. So to apply this one, I am going to write this may be written as s into s divided by s square plus 4 whole square, right? So you will get the clarity here, you will get an idea here. Let f of s is equals to s divided by s square plus 4 whole square, right? So f of s is equal to s divided by s square plus 4 whole square. Now I am going to find the inverse Laplace transform of this one, or listen, before that, just I'm not taking s square here. Listen, let f of s is equals to 1 divided by s square plus 4, which is s square plus 4 whole to the power of minus 1. That implies d by ds of f of s is equals to, here it is d by ds of s square plus 4 whole to the power of minus 1, which is nothing but minus 1 into s square plus 4 whole to the power of minus 1 into s square derivative is 2s. So which is minus 2 into s divided by s square plus 4 whole square. This is the derivative of f of s, right? Now we have the transformation of the derivatives theorem here. Transformation of the derivatives, what we have, this is the L, therefore L inverse of now I am going to apply this one, d by ds of f of s is equals to, here it is minus 1 whole to the power of t to the power of 1 divided by ds to the power of 1 minus 1 to the power of 1 t to the power of n f of t here, f of t. But when I am taking f of s is equals to, since f of s is equals to 1 by s square plus 4, so that implies L inverse of f of s is equals to 1 by L inverse of 1 divided by s square plus 2 square. So this is same as a divided by s square plus a square, that is sin 2t divided by 2, yeah, which is equals to L inverse of d by ds of f of s, which is equals to minus 1 to the power of 1 t to the power of 1 f of t. But d by ds of f of s is equal to what? Minus 2. Yes, this can be written as L inverse of, listen, here what is there here, minus 2 into s divided by s square plus whole square plus 4 whole square is equals to minus t f of t, sorry, here capital F of t, right? This can be written as, listen, you take out minus 2 to the left side, minus 2 L inverse of s divided by s square plus 4 whole square is equals to minus 1. F of t we have sin 2t divided by 2. Both side minus minus get cancelled. That implies L inverse of s divided by s square plus 4 whole square is equals to sin 2t divided by, you take out this 2 to the right side, which is 4. Yes, this is the statement we have. So here it is. Now I am going to take, let g of t is equals to, or g of s is equals to, already we taken f of s, so that's why I am taking g of s. Let g of s is equals to s divided by s square plus 4 whole square, and g of t is equals to sin 2t divided by 4, and g of 0 is equals to sin 2 into 0, sin 0 by anything, it is 0. So we can apply this statement here. So if you are applying this, so what we have, L inverse of s into g of s, s into g of s, s into g of s is equals to, from that statement what I am writing, g dash of t you need to write, g dash of t, sorry, capital G dash of t we need to write it, right? Here that implies L inverse of s is what, s into g of s, what we taken, s divided by s square plus 4 whole square is equals to g of t, that is d by dt of g of t. So which is d by dt of g of t is sin 2t, sin 2t divided by 4. Sin 2t is cos 2t. Sorry, into t also there, no? Sorry, here it is. In the previous we have the t here. T sin 2t, t sin 2t by 4. So therefore 1 by 4 into the derivative, t into sin 2t derivative is what, cos 2t divided by 2 plus sin 2t into t derivative is 1. So finally what we have, L inverse of s square divided by s square plus 4 whole square is equals to, so finally we can write it, it is 1 by 4 into, this is 1 by 4 into t cos 2t plus sin 2t. Listen, you just here to find, just I am going to recall the problem here. To find in this one, to find s square divided by s square plus 4 whole square, is first I taken f of s is equals to 1 by s square plus 4. So L inverse of f of s is what we have, L inverse of f of s is equals to, here it is sin 2t divided by 2, but L inverse of d by ds of f of s is equals to, here we have L inverse of d by ds of f of s is equals to t sin 2t divided by 4, t sin 2t divided by 4. This can be taken as g of s, this can be taken as g of t. Listen, that can be taken as, in the previous I written this one, no, sin 2t divided by 2, t sin 2t divided by 4 taken as g of t. So g of t, the derivative of g of t is, this is t cos 2t plus sin 2t. This is the problem. Next, last theorem in the finding the inverse Laplace transformation, that is very important, that is convolution theorem, then followed by the applications of the inverse Laplace transformation or Laplace transformation. Convolution theorem. Right, the statement of the convolution theorem is, we use this theorem to evaluate the inverse Laplace transform in the easy way, right? So sometimes we may go for the previous, as we discussed now, previous theorems or previous statements. As if mentioned in the problem, apply the convolution theorem, evaluate the inverse Laplace transformation. So you go for this one. The statement is, if L inverse of f of s is equals to, if L inverse of f of s is equals to f of t and L inverse of g of s is equals to g of t, then L inverse of f of s into g of s is equals to integral 0 to t f of u into g of t minus u du. This is the statement of, that is product of the two functions of s, two function of s, right? F of s into g of s is equals to integral 0 to t f of u g of t minus u du. Note that if I am changing the order here, is L inverse of some g of s into f of s if we write. So here it is what you are going to expect here, that is g of u into f of t minus u du. That means there is no effect for taking the first function f of u or g of t minus u. If you take f of u, this one, so L inverse of g of s, we can take g of t minus u. If you take g of u, then L inverse of f of s, from that L inverse of f of s is equals to f of t. From this you are going to take f of t minus u du. This is a statement of the convolution theorem, right? If we have L inverse of f of s is equals to function of t, L inverse of g of s is equals to function of t, that is g of t. F of t is the inverse Laplace transform of f of s, g of t is the inverse Laplace transform of g of s. Then L inverse of the product of these two functions of s, f of s into g of s, is given by integral 0 to t f of u g of t minus u du. This is called convolution theorem. Proof also there, but in our syllabus proof not included. Right. Now coming to the problems on the convolution theorem. Let's use the convolution theorem, evaluate the following. Now first one, L inverse of 1 by s plus a into s minus b. Just if the problem like this, evaluate inverse Laplace transform of like this. You go for the what? Decompose into partial fractions, you will get the answer, right? But if we mention the question, right, using convolution theorem, evaluate the integral, the inverse Laplace transformation. So here it is, that means if you see the bracket term, inside the bracket term, you will get an idea. This one 1 by s plus a can be taken as f of s, 1 by s plus b can be taken as g of s. Let f of s is equals to 1 by s plus a, g of s is equals to 1 by s plus b. L inverse of f of s is equals to L inverse of 1 by s plus a, right? That the direct statement is e to the power of minus at. This can be taken as f of t, right? The L inverse of g of s is equals to L inverse of 1 by s plus b, which is equals to e to the power of minus bt. This is g of t. As you by convolution theorem, we have L inverse of f of s into g of s is equals to integral 0 to t f of u g of t minus u du, right, which is integral 0 to t. We have f of t is what? E to the power of minus at. F of u is what? E to the power of minus au. G of t is e to the power of minus bt. G of t minus u, just replace t with the t minus u, that's all. E to the power of minus b into t minus u du, which is same as integral 0 to t e to the power of minus au e to the power of minus bt, minus into minus, e to the power of bu du, right? Here integration with respect to u, this is the independent of u, you take out the before the integration, so which is equals to e to the power of minus bt integral 0 to t. Yes, here e to the power of what I am writing here, e to the power of b minus a into u du, right? E to the power of bu into e to the power of minus au, e to the power of b minus a into u du. So which is e to the power of minus bt. The integration is e to the power of b minus a into u divided by b minus a, where u is equals to 0 to t. E to the power of minus bt divided by b minus a, b minus a is a constant, of, if you write e to the power of b minus a into t minus e to the power of u is equal to 0, it is 1. So which is 1 by b minus a, e to the power of minus bt, e to the power of bt, minus bt plus bt cancel, e to the power of 0, minus e to the power of minus 80, minus 80, minus e to the power of minus bt. So therefore L inverse of 1 by s minus a into s plus a, sorry, s plus a into s plus b is equals to e to the power of minus 80, e to the power of minus bt divided by b minus a. This is the problem on convolution theorem. Like that we take another problem. Right. Next, evaluate L inverse of one by s square of s square minus a square. Right. Okay. If you go for the partial fraction also, resolve into partial fractions, you will get this one. Right, here it is, you may take, let f of s is equals to 1 by s square, that implies L inverse of f of s is equals to L inverse of 1 by s square. So it is an integer 1 plus 1. Here it is t to the power of 1 divided by 1 factorial, that is n factorial, that is 1 factorial, which is t. This is same as f of t. Okay. Next, g of s is equals to 1 by s square minus a square, that implies L inverse of g of s is equals to L inverse of 1 divided by s square minus a square, which is equals to what we have, what we are going to write here. So here L inverse of some constant divided by 1 divided by, if you are multiplying with a, dividing with a, 1 by a of a divided by s square minus a square sin hat. So here 1 by a is there, sin hat divided by a, say this is g of t. F of t is equals to t, g of t is equals to sin hat by a. Next, now up you by convolution theorem. Listen, if you take that g of t, listen, if I write the convolution theorem, L inverse of f of s into g of s is equals to integral 0 to t f of u g of t minus u du. Actually this is the case, no? What I am doing here, this is same as, if you change the order, this is same as integral 0 to t g of u f of t minus u du, right? What is the reason for interchanging the terms? Here if you write, if you take g of t is equals to that one, so g of t minus u becomes h of sin hat of t minus u. There is a problem, not a problem. That means compared to t, this is a big term. The differentiation also, it is not easy. So in that case I am changing like this. So it becomes, what is the meaning here? That means you are taking f of s is equals to 1 by s square minus a square, and g of s is equals to 1 by s square, right? So it is integral 0 to t g of u it is nothing but sin hat sin hau by a into, what is there here, f of t is equals to t, f of u is equals to t minus u. Here it is t minus u du, right? We go for what? U into V, first function into second function into first function. So here it is 1 by A is a constant, and listen, t minus u into integration. Here sin HAU integration with respect to u, here it is minus or cos HAU divided by A. Is it clear? Sin hx integration is cos hx integration is sin hx, where here if you write the u limits, u is equals to 0 to t. Next, minus integral, same here, sin HAU integration is cos HAU by A into d by du of t minus u is minus 1 into du 0 to t. Listen, now coming to the limits, 1 by A of, this is the first term here, 1 by A of, listen, if you go for upper limit, right, t minus t 0 into anything, it is 0, right? If you go for lower limit, t minus 0, that is t into cos 0, it is 1, cos h into 0, cos 0 is 1, so it is t minus 0, here it is minus of, first one it is u minus u is 0, t minus t is 0, 0 minus t divided by A. Is it clear? Next, minus into minus plus 1 by A square, sin it is cos HAU, sin HAU, where the limits are from where to where? U is equals to 0 to t. Okay, now which is same as 1 by A, it is minus t by A. If you go for plus 1 by A square, sin HAT, sin 0 is 0. Okay, what you are going to take here, 1 by A cube is LCM here, first A square is LCM there, so A cube, A square is LCM, minus AT we have, so sin HAT minus AT, this is your answer. Sin HAT minus AT divided by A cube is the inverse Laplace transform of 1 by S square into S square minus A square. This is the way. Yes, next. Next problem, third one, L inverse of 1 by S plus 1 into S square plus 1. Right, if you go for this one, A divided by S plus 1 plus BS plus C divided by general procedure. That is also useful. That means based on the given problem, based on the time, if it is mentioned, compulsory we apply the convolution theorem. Right, here it is, you will get that, here it is, let f of s is equals to, I am taking 1 by s plus 1, that implies L inverse of f of s is equals to L inverse of 1 by s plus 1, which is equals to e to the power of minus t, say this is f of t, g of s is equals to 1 by s square plus 1, that implies L inverse of g of s is equals to L inverse of 1 by s square plus 1 square here. Here it is a divided by s square plus a square, sin at. Here it is sin t. This is g of t. Right, sin t. Next, that implies L inverse of, by applying the convolution theorem, f of s into g of s is equals to integral 0 to t f of u g of t minus u du. This is your choice. If it is possible to evaluate sin of t minus u du, you write it. Otherwise you can take that is, this is same as integral 0 to t g of t f of t minus u du. It is very easy, right? Sorry, g of not g of t, g of u. So integral 0 to t g of u is what? Sin u into e to the power of minus t minus u du. So it is e to the power of minus t, you can write it before the integration, integral 0 to t minus into minus plus e to the power of u sin u du. It is in the form of integral e to the power of ax into sin bx dx. Yes, it is e to the power of ax divided by a square plus b square, b sin a sin bx minus b cos. That by using that formula, yes, you will get the function that is your required in answer. Next. Yes, evaluated. Just if you simplifying this, you will get the answer. Next. Next one. L inverse of 1 divided by s into s plus 1 whole cube. Right. This is what are the choices for taking f of s and g of s? F of s is equals to 1 by s. L inverse of f of s is equals to L inverse of 1 by s, which is equals to 1. L of 1 is equals to t. This is your f of t. G of s is equals to 1 by s plus 1 whole cube. That implies L inverse of g of s is equals to L inverse of 1 by s plus 1 whole cube. So in this case, first you take out the exponential function before the inverse Laplace transformation. It is e to the power of plus 1 is there, minus t, L inverse of 1 by s cube. So which is e to the power of minus t, L inverse of 1 divided by s to the power of 2 plus 1. E to the power of minus t, 1 by s plus 1, t to the power of n divided by s to the power of n plus 1. T to n is n being positive integer. T to the power of n divided by n factorial, that is 2 factorial. Is it clear? Okay, that is your g of t. This is your g of t. Now, by using the convolution theorem, f of s into g of s is equals to integral 0 to t f of u g of t minus u du. Here also same case, right? Yes, if you take e to the power of t minus u whole square 2 factorial, better to try it. This can be written as integral 0 to t g of u f of t minus u du. So integral 0 to t g of u e to the power of minus t, it is u square by 2 factorial, it is 2, into f of t is equals to 1, f of u is equals to 1, f of t minus u is also 1 du. So if you find this integration, 1 by 2 into the integration, listen, as it is a u square into e to the power of minus e to the power of minus t, next minus 2u into that minus into minus plus e to the power of minus t, next plus 2 into minus e to the power of minus t, not t, u here. Here also u. Right, where the limits are 0 to t. Is it clear? The integration, listen, the integration is what? Here the function u is what? U is u square and v is e to the power of minus u. 2u minus e to the power of minus u. 2 e to the power of u. Next minus e to the power of minus u. So in this way we are multiplying this to apply the integration by parts. Integral u into v dx, u square e to the power of minus u, alternatively positive and negative. Next 2u into e to the power of minus u, minus is there, next term is plus 2 into minus e to the power of minus u. Yes, if you take that limits, we have 1 by 2. So it is first t square, no? Minus t square e to the power of minus t, minus 2t e to the power of minus t. Next here it is minus 2 e to the power of minus t. Okay, next 0. If you write 0, this one is 0, this one is 0, only this term we have this term only. This, and e to the power of 0 is there. E to the power of 0 is equals to 1, minus is there before minus, that minus and minus, plus e to the power of 0 is equals to 1, 2. So finally what we have, you can write it. If you common e to the power of t or e to the power of t, if you common, we will get the, or dividing with 2. So we have 1 minus e to the power of minus t as t square by 2 plus 2t plus 2. This is your answer. This is the inverse Laplace transform of 1 divided by s into s plus 1 whole cube. Sorry, 2 yes, dividing with 2 we don't have 2, right? Here it is t, here it is 1. Next. Next one, already we did this problem, again we are trying. L inverse of s divided by s square plus a square whole square. S divided by s square plus a whole s square plus a square whole square. Listen, let f of s is equals to s divided by s square plus a square, that implies L inverse of f of s is equals to L inverse of s divided by s square plus a square, which is cos at. This is f of t, say g of s is equals to 1 divided by s square plus a square. L inverse of g of s is equals to L inverse of 1 divided by s square plus a square. This is nothing but sin at by say this is g of t. Yes, by applying the convolution theorem, L inverse of f of s into g of s. This is same as L inverse of s divided by s square plus a square into 1 divided by s square plus a square, integral 0 to t f of u g of t minus u du, integral 0 to t f of u cos au into sin a into t minus u. Here it is no problem. If you are writing, if you are interchanging g f of u, j of t minus u, here also we get the same case, cos a of t minus u divided by a du. So which is 1 by a of, better to write this, 1 by a of integral 0 to t, here it is cos au, yes, here it is sin of at minus au, right, sin a minus b, sin a minus b, sin a cos b, sin at cos au minus cos at sin au, here it is du, right. So this can be written as 1 by a of integral 0 to t multiplying with sin cos au, sin at cos square au minus cos at sin au cos au du. Here now separating the integral, 1 by a or sin at by a is independent of, with respect to sin independent, right, sin at by a independent of u, integral cos square u. So 2 cos square x minus 1 is equals to cos 2x. 2 cos square x is equals to 1 plus cos 2x. Cos square x is equals to 1 plus cos 2x divided by 2. So this can be written as 1 plus cos 2x cos 2au divided by 2 du, right? Next, minus cos 8 is a common, cos 8 divided by a, it is 2a I am writing. It's multiplying with 2, dividing with 2, 2 sin a cos a is equal to sin 2a. Here it is integral 0 to t sin 2au du. Yeah, which is sin at by a. Now coming to the integration, or 2a, better to write 2a. Du it is nothing but u. Cos 2au integration is sin 2au divided by 2a, where the limits are 0 to t, minus cos at divided by 2a. Integration of sin is minus cos 2au divided by 2a, where 0 to t. If you substitute the limits, right, it is sin at divided by 2a, right, upper limit t plus sin 2at by 2a. Next, lower limit 0, sin 0 is 0, the complete term is 0. Next, minus cos at divided by 2a, or minus into minus plus, cos 2at by 2a, minus cos 0 is 1, minus 1 by 2a. Right, if you are simplifying this, yes, we will get the answer. It is 280 we have, 1 by 4a square is the LCM there and there. Here it is 2at sin 80 plus sin 80 sin 280 plus cos 80 cos 280 minus 1. But if you are simplifying, if you are writing 1 minus cos 280, here 1 minus cos 280 is there, no? If you are writing cos 80 of 1 minus cos 80 will get. If you are writing 1 minus cos 280 or cos 280 minus 1, if you take this one, if you write this is minus, here we will write 1 minus cos 280, right? Here sin 280 is that's 2 sin 80 cos 80. 2 sin 80 cos 80, 1 minus cos 280 it is 2 sin square, it is cos 2x is equals to 1 minus 2 sin square x, 2 sin square x is equals to 1 minus cos 2x, that is 2 sin square 80 there, which is 1 by 4a square, 280 sin 80 plus sin 80, 2 sin 80 cos 80 minus cos 80, 1 minus cos 2x it is 2 sin square x, 2 sin square 80. Yeah, this can be written as this one I think sin 80 2 sin square 80 cos 80, 2 sin square 80 cos 80, these two terms get cancelled. So we have, which is 280 sin 80 by 4a square. So 280 sin 80 divided by 4a square. So we have 2 ones are 2 twos are, a get cancelled, which is equals to t sin 80 divided by 2a. This is the answer. T sin 80 divided by 2a. This is a way of evaluating the integration. Like this, we are trying to solve these problems. Is it clear? If you are multiplying this term and this term get cancelled. Evaluate L inverse of the same way s square divided by s square plus a square whole square. L inverse of 1 by s minus 1 whole to the power of 5 into s plus 2. L inverse of 1 by s into s square plus 4 whole square. L inverse of 1 by s into s square plus 2s whole square. L inverse of 1 by s square is plus 1 whole square. L inverse of 1 by s into s plus 2 whole cube. These problems, right? This is about the convolution theorem and problems.